lot of solid to do with SolidWorks when you're building. You can do with objects that are round in one or more of the axes. You can move. But being able to, if you can use, we can use integration and ultimately if we know the volume and we know the mass per unit volume and the material, calculate its weight and so on. And as Lewis will probably tell you, there are utilities in SolidWorks that will tell you what the mass of the mass sorts of extra. So let's take a little look at what we might be doing in simplistic terms. If we consider with a and the x-axis equal to 1. Highlighted in green. If we reverse 300 degrees around, we would end up with a cone. Yep. So, what we're going to do is consider how we can use the volume of that. If we take a thin slice of width dx, we but dx so that would be the x is there, let's say 0.7 or whatever. Agreed? Yeah. The volume r squared, that's the area of a circle. Yeah. By in some cylinder here would be the width dx of that slice. Yeah. Because the radius, each disk dx high, we can note that the slice is v to r times y squared, so we replaced r dx. Yep. So now we've got the now what that we're talking about, very thin slice cone into a very thin cylinder. Pi times y squared is 1, and if we multiply it by the width of that slice, we've got the volume of that slice. Integration then does as it sums the slices between r 0 and 2 if our cone hits 2 there. So if we keep between the two limits, that function, we get the volume of. So, right, the integral limits are 8. We just integrate y squared with respect to dx. So that gives us our volume. Right? So when integrate y and multiply pi, get the volume. You will do. Alright? If we r is equal to a function, and that's the equation who's being rotated, and I have a rotated, and x and because equally we could rotate a function and today. On I to our original problem with I dx that now equal into if they're not meat. Or anything. if we want control unit. And as you thought that was going to be, revolve solids, because the function set right the formula volume of a curve is V is equal to over 3. Pi over 3 equals 3 pi units cubed. Yep. So it checks out formula now. Yeah. You got a formula to prove is y is equal to function. Then we look at revolving and x is equal to 4. Determine the volume of solid what we're going to integrate and where between. Any you do is the radius of each slot multiplied by pi to twice. You go the integral eigen volume So we can't do that. Where to multiply x squared plus 4 is x squared plus 4. To the power 4. Right now, if you go the volume of that solid, you should have area is equal to pi times x to the 5 over 5 plus 8x to the 3 over 3 plus 16x between 1 and 4. That's, I haven't given you meters, but if they were meters, that would be meters cubed. So if these two scales were in meters, if that was 20 meters and this was 4 meters, then the result would be meters cubed, wouldn't it? Without being given anything, that's just cubic units. So that's pi times 4 to the 5 over 5 plus 8 times 4 to the 3 over 3 plus 16 times 4 minus 1 over 5 plus 8 over 3 plus 16 equals pi times 204.8, which is that bit, plus 170.67, which is the 8 times 4 to the 3, plus 64, minus 0.2 plus 2.67 plus 16, include both sets of brackets, and if you total all that up, that's 420.6 pi units cubed. Yeah, so if the two scales were meters, that would be meters cubed. If they were centimeters, that would be centimeters cubed. And if we multiply 420.6 pi you get 1,321 cubic units. Don't we, Lewis? Yeah. And going back to estimating that, if we look at the diagram, if we take the block that might be machined out of, yeah, that would be 20 by 20. So the area of that is 400. Yeah. And then we got to multiply that by the 4 units across there to get the volume. Yeah. That's going to go. Yeah. So just trying to estimate, are we in the right ballpark with the result that we've got from what the block that might come out of. Yeah. Right. Find the volume of the solid created if the curve y equals x cubed plus 1 is rotated around the x-axis between the limits of x is equal to 0 and x is equal to 3. So I'm going to leave you to do that one completely on your own, right from the start. And then we'll go through a worked solution. Let's just run through. So we've got y is equal to x cubed minus 1. Volume, therefore, is equal to pi times the integral between 0 and 3 of x to the cube minus 1 all squared dx. That is pi times the integral between 3 and 0. Then we've got to multiply this out, so we get x to the 6 plus 2x cubed plus 1 dx. Agree? Is that what you've done? Yeah. And then that equals pi times square brackets x to the 7 over 7 plus x to the 4 over 2 2x to the 4, 2x to the 4 over 4, and then you cancel the top 2 out and let me show you. That's 2x to the 4, correct. Divide by the new index, yeah, and then you can cancel that and make that 2. Don't have to do that, but that's just, yeah. Alright, same thing. So if you've got it as 2x to the 4 over 4, no problem, same thing. Alright, plus x between 0 and 3. Well, it depends what's in there. If there's a cosine function, then that's got a value when x is 0, so you have to be careful. All right? Yeah. Not always, but usually that simplifies in some way. So we all agree that's worth nothing when x is equal to 0. So all we got to do is evaluate it when x is equal to 4, and each part of that becomes pi times 355.93 units cubed, which is 1118.2 units cubed.
whole number, or is that?
I think in general, leaving it as 355.93 pi would be fine. If I've given you units like meters for the scales, then you need to recognise, you should be recognising here that these units to be applied, either cubic or square units if I've not given you a particular unit. But if there is a particular unit, you should be recognising that and including them. Okay? Right, over the page there are some examples for you to have a go at. 3 examples of finding areas of curves and 2 examples of finding volumes of solids. Alright? You may well need to use some kind of graph to determine your limits.